Finally, if you multiply your function by a negative, you're going to flip it over the x-axis. If you multiply your function, if you make x negative, I'm going to flip it over the y-axis, but since it's symmetric of the y-axis, there's going to be no change. It's just going to be exactly the same. So if I take a look at example 9, I want to describe each transformation as it's related to the graph of its parent function, and then I want to verify my answer with technology. So I'm going on example 9, because it's negative, we're going to flip it over the x-axis. Then I'm going to do a vertical dilation by a factor of 2. Vertical stretch. So let's take a look at that one. So I'll have y equals negative 2x squared. And see what happens here? Let me raise my graph up a little bit so you can see a little bit nicer. Each point has been flipped over the x-axis, then I've doubled it. So I've taken like this point right here, I've flipped it over, and I've doubled its value. Now inside, I don't know why, I don't like green. I was trying to get a different color there. Okay, p of x equals negative 2x squared. So what's happened here, I'm going to flip over the y, which means really I'm not going to change it because it's symmetric. And then I'm going to do a horizontal compression by a factor of 1/2. So I'm going to take each x value, I'm going to multiply it by a half, and I'm going to plot it with the same y value. So let's take a look at that. So I think I'll just start over here. So I'll have g of x equals, and then I go parentheses, negative 2x, close the parentheses, then I'll square that. So now, I flipped it over the y-axis, so you really can't tell the difference, and I took each x value multiplied by 1/2, and that's why it looks thinner. It's been horizontally compressed by a factor of 1/2. So you're looking at what does each number do to your equation. So if I take a look at example 11. Example 11 says, the path of the center of gravity of a dancer during a leap can be modeled by the polynomial g of x equals negative 0.17 times x minus 3 the quantity squared plus 1.53, where x is a horizontal distance in feet of the center of gravity from the starting point h of x. It's the vertical distance in feet. Describe the transformations as it relates to the graph of the parent function. So related to x squared. What's going on here? Well, first off, this negative flips it over the x-axis. Then I'm going to vertically dilate it, or in this case compress it, by 0.17. In other words, it's going to get wider. I'm going to push down on my graph. Then I'm going to slide to the right 3. And I'll push it up 1.53. Now let's verify that. So I'll do my parent function here. So I've got g of x equals, I'm going to go negative 0.17 times x minus 3 and then what we say we're going to go up 1.53, so plus, whoops, got my square in the wrong spot. I close the parentheses, then square. Whoa, too much stuff here. There we go. Then I'll add 1.53. And so I see my vertex is at 3 and 1.53. I flipped it over the x-axis and I've vertically compressed it so it looks like it's wider.